Robot Talk is the podcast that sits down with roboticists from around the world and asks them the questions you always wanted answered. Like, can we work with robots? And how does that thing work? Hello everyone! Welcome to Robot Talk. I'm your host, Claire Asher, and this week we're returning to the topic of human-robot collaboration in industry. I'm finding out how collaborative robot arms are changing manufacturing in the UK, and what the future might hold for humans and cobots. Before we get started, this is your regular reminder that you can contribute to the conversation by sending in questions for my future guests. I announce upcoming guests on social media and Patreon, so make sure you follow the podcast to find out what's coming up. You can submit questions on the website at robottalk.org, on Patreon at patreon.com/Claire Asher, or by replying to one of my guest announcements on social media at Robot Talk Pod. So, with all that said, it's time for me to introduce this week's guest. I recently had a wonderful chat with Mark Gray from Universal Robots about their lightweight robotic arms that work alongside humans. Today, I'm speaking to Mark Gray, UK and Ireland manager at Universal Robots, who's bringing collaborative robots to manufacturing and industry across the UK. Hi Mark, great to have you on Robot Talk.
Hi Claire, thanks for having me.
So, Universal Robots is a world leader in the field of collaborative robots, or cobots. But for listeners who might not be familiar, can you tell us a little bit about the company?
Yeah, so we're about 20 years old. We were started in a little town called Odense in Denmark, and we're the first commercial manufacturer of cobots. So we've sort of led that field for many, many years and gone into many diverse applications. So we have robots all over the globe now. We've more than 110,000 robots deployed into different sort of sectors of manufacturing, the arts, there's all sorts of different things.
Fantastic. And what was the driver behind launching the company in the first place? I mean, what inspired the founders to really lead the way on commercial cobots?
It was founded by 3 university professors who did a research project to look at why small companies in Denmark wouldn't use robotics and automation. And most people would normally have filed that research and done nothing with it, but these guys decided there was an opportunity to develop a 6-axis robot arm that met all those challenges and actually solved them. And that's where the world's first cobot came from. So they started to sell into Denmark initially and then all over Scandinavia. And then they were bought out and expanded, and we're now like a truly global company.
Mm-hmm. That's a fantastic story. So what were the challenges that were stopping people from implementing robots that they then designed this cobot arm to address?
So typically robots in the past have always been really complicated things to install. You had to be a high-level programmer, and robots were designed for one task. So they didn't really solve machine shop sort of problems where you need to change jobs really quickly, small production runs, that sort of thing. And they needed to be flexible enough that they could set them up quickly, because small companies don't have a great deal of time to set something up for commissioning for months and months. So that was the things they concentrated on. They wanted to make something that was really simple to program, very flexible, could be set up quickly, and it could be moved around the factory floor as well, so it could be redeployed. Yeah. And those are the sort of main things that have made cobots really useful for manufacturers and opened up new sectors of automation that just didn't exist before, really.
Yeah. So, I mean, as you've kind of just explained, like, robots have come a long way from those early industrial robots of the 1970s, which was probably the first kind of robot I ever became aware of existing. You know, those big industrial robot arms that were quite often kind of confined behind a cage. And as you said, weren't necessarily that adaptable. They were quite often very task specific. And we're now seeing humans working much more closely with robots in a variety of different industries. But I'm sure there's always more work to be done. So what are the biggest remaining challenges in making robots that can work effectively, efficiently, and most importantly, safely with humans?
So skills is one of the big things. For adoption, there's a real lack of people with the right skills for programming to get things into manufacturing sites. But we're on the verge of AI. So AI is a really interesting thing in the fact that robots can be taught those skills, and that makes it easier to be redeployed and easier to set up. So we're right on the precipice of that becoming a reality in manufacturing, AI being able to be physically manifested into robots programming. So that's a really interesting avenue of the next sort of 5 years of how AI is going to transform robot programming and deployment. And that goes into everything for safety, for setup. We talk about the sort of 3D tasks, the dirty, dangerous and dull tasks. But if we take something away, we've got to give something back, haven't we? So we talk about the 3B, the 3 benefits: better quality, better productivity, but more importantly, better welfare for the staff that is going to work alongside. Robots can take over those kind of repetitive tasks that might, in long term, injure people, lifting heavy boxes, using vibratory tools to deburr things, putting things in and out of machines. Robots can take over those sort of tasks and free up people to use their skills a lot better. They can use them for quality inspection, actually programming the robots themselves. So there's a big part of that, being able to alleviate where we are now with the next set of skills, and also using AI to be able to deploy these robots much more widely and make them much more useful to manufacturers.
So would you say that it's mainly software that's the barrier now rather than hardware?
I would say that the barrier really is programming. Our software is very simple, but it's still something you need to know how to deploy into a factory setting. And most manufacturers, they're just not set up to adopt automation. So that's the challenge that we have in front of us, to try and make it simpler and easier for people to see the real benefits. Because there are lots of simple tasks that can still be automated. And we need to automate because we need to be competitive on the global market. We look at other countries like South Korea, China, Germany, they're heavily automated. And for us to be able to be a manufacturer, we need to play in that same play park, if you like. So we need to automate at the same level.
Yeah. I mean, I guess what you ultimately want is a robot that, to program it, you don't have to know any code. You don't even have to sit down at a computer. You can just teach it in the way you would teach a human, a new staff member that you're kind of onboarding.
We actually have an event in Sheffield in March, which is all around AI and how it can be used in practical terms with robotics. And one of the companies that are going to exhibit at that show, you can actually program a robot from text. So you type in what you want it to do, it'll translate that into real world moves, and the robot will do what you actually tell it. That opens up a really exciting challenge for people to be able to put robots into their factories now by being able to just type a command to it and it will understand those commands.
Yeah, that's really cool. Although the skeptic in me, thinking about some of the conversations I've had with like ChatGPT and stuff like that, when it doesn't quite go right, I think there's still a little bit of refining in that technology to be done.
That's the thing with AI, it only gets better, doesn't it? The more things it does, the more it learns, the better it gets. And we're right at the start of that, I think. So within 10 years, I think it'd be really transformative, the technology of how it's going to work with automation. It's a really interesting field, actually, to be right at the start of it now.
Yeah, absolutely. So, a concern that a lot of people have about the growth of robotics, and I think this has been becoming a bigger concern recently with the developments in AI, people are worried that robots are going to take their jobs. But, the name collaborative robot, as it suggests, they are designed to work alongside humans rather than replacing them. So, what would you say to someone who, for example, works in manufacturing, who's worried that they're going to lose their job to a robot?
So it's a age-old question, this. I often wonder where the origin story is, because whenever you speak to any company that's put robots in, they haven't had mass redundancies.
Yeah.
They've actually increased productivity. And there are examples that we've worked with companies in Denmark where they've put 40 robots into the factory, redeployed the staff, and it's actually created an extra 60 jobs. Nobody gets rid of people when a company becomes more productive. That's a big problem that we have in the UK, is a lack of productivity. And machines make people more productive. So we could take away tasks that are really slow and difficult for humans to do, let robots do those, and then let people concentrate on the tasks that they are really good at. So we don't think that people will lose their jobs to a robot. They actually think it'll probably enhance their jobs. If you think about a human and a robot working together in a cell, that blend, it increases output, it increases productivity. Every time you need to pick up a tool to do a task, if you let the robot do that and let the human concentrate on assembly while the robot's putting screws in or dispensing glue, it's increasing the output of that cell. So we don't think people will lose jobs. We think it'll actually enhance their future sort of work, really.
Yeah, I guess the concern I have sometimes is that, a company might implement a load of robots. They're not necessarily getting rid of the total number of employees overall, but those jobs are changing. And it's whether those methods to reskill people and to train them to do the new jobs are available. And I guess in this case, it might be reskilling to work with a robot rather than the tools that you've been using for 20 years or whatever. So I think if that's in place, then that's great. But that's where my slightly more nuanced view of concerns comes from, I guess.
I think everybody's got a responsibility to teach the next generation of how they can work with technology. If you think back 40 years, it was unthinkable that you would have a PC on the shop floor to log data. And now it's commonplace. People need to know how to work a computer if you're going to work in manufacturing. So it's just like that. It's adopting a technology that's making it easier and making your product better is a necessity, really.
Yeah. And I guess in an ideal world, robots can come in and take over, like you said, the 3D jobs and let people do more technically challenging, more interesting, more intellectually stimulating jobs. That's the kind of utopia, I guess.
We say that human skill is the single biggest asset to any manufacturing business. People's eyes, people's hands, people's skills, decision-making skills are absolutely paramount. If you've got somebody making decisions on quality for inspection, complex decisions on how to pick products up, how to assemble products, robots are miles away from that at the moment. And that's what we want. If you're going to employ somebody, you want the very best out of them and you want the very best for them. So it's a kind of two-way street, really. People, if they can elevate their skills, they're more employable, they'll earn more money, living standards will increase. It's an age-old sort of story, really.
Yeah. So you mentioned, obviously, Universal Robots has loads of robots all over the world. What are kind of the most common use cases or applications for these robots?
So in food and packaging plants, it tends to be just lifting boxes from the end of production lines to put them onto pallets or packing products into boxes. In the machine shops, it's loading parts in and out of CNC machines or into press brakes, all those sort of simple stuff. And then in things like automotive, it's assembly, screwdrivering, dispensing glue, putting components together. There's lots of sort of standard products, standard applications that we see. And there's still lots of those still to be automated out there on the factory floor.
Mm-hmm. Have you seen any really novel uses?
There's some really cool ones, actually. There are some really, really cool applications out there. Usually the coolest ones I can't speak about because I signed NDAs on. Sure. But there are really useful ones for quality inspection. So you could mount a camera on the end of a robot and move into something and carry out much more complicated measurements or inspections than a human could. And that's a thing where it's actually carrying out a task that a human couldn't do to that sort of degree of accuracy and dexterity. So there's lots of really, really sort of cool inspection sort of applications. It's limitless. Every year we always say what the coolest thing about this job is we encounter new things that we've never seen before. Yeah,
it sounds like a really fun job. What does your day-to-day look like? Is it a very varied job? Are you out and about a lot? Are you usually in the office? What's your day-to-day?
It is very varied. I've been more office-based recently, but when I first started, I was literally out 5 days a week, all over the country, seeing lots of different applications. I've got a team of people that work with me in the UK, and we have customers all the way from Plymouth right up to Inverness and everywhere in between. We do road shows where we take the robots to different cities to show people the technology, rather than actually asking them to go to a big exhibition. And we've done over 60 of those all over the UK. And we've got some planned for this year. And they're going to be really interesting because we're focusing on things like AI, packaging, machine tending. So it's tailored around a specific application or a specific technology. So that's something for the future.
Cool, yeah.
It is really interesting. This job is there's so many different aspects that we look at, and it's always changing. If you'd said to me 10 years ago, the kind of companies we will be dealing with now, I couldn't have comprehended that. It's so different.
Yeah.
And that's what makes this job really interesting.
Fantastic. So I've seen you describe yourself as the cobot guy. So
Yes.
How did you get into this field? What attracted you to collaborative robots?
So my background, I was in vision systems and inspection before, and I was selling into the automation marketplace. And we were looking at taking on Universal Robots as a distributor at my previous company. And I went to meet a Danish guy about becoming a distributor. And it was one of those meetings where you're only supposed to be there for 30 minutes. And we sat there for 4.5 hours. He just got on like an absolute house on fire. And at the end of it, he folded his arms and he said, "Can I be honest with you?" And I said, "Yeah, of course." And he said, "I'm actually looking for a UK manager. I've come over here to interview people. I don't like anybody I've met. I want you to do it." So what was initially a meeting turned into a job interview, and I'm here nearly 10 years later.
Wow.
So that's how I got into it. And when I started 10 years ago, we were right at the start of collaborative robots coming into the UK. We have something like 3,500 deployed in the UK now. And it's been a roller coaster ride. It really has, to see the different applications, the different companies that have adopted them, and the success stories that we've had as well.
Well, I love the kind of serendipitous sequence of events there. Do you have any collaborative robots in your home? Do you have any personal cobots?
No, not at the moment. I'm sat in the office in Sheffield here today, and we've got about 20 robots here. We actually have a mobile robot. So the other part of our business is a mobile robot base, and we have a robot and a cobot combined. So it can move around the office and bring things to us if we want, but we haven't programmed it for that yet.
Right. Oh, you've not got it bringing you cups of coffee yet then?
That's in the pipeline. We've only got it on Monday, so that's in the pipeline. We'll have a button that we just press and it can bring a coffee to us.
I mean, that's the dream, isn't it?
It is.
Did you see the report that was published last year about why the UK doesn't make more robots? And what were your thoughts on that?
I did. So there's lots of talk about this, about how we're behind the rest of the G7 countries on our adoption of robotics. Collaborative robots kind of sits parallel to that. The traditional industrial robots we've been slow to adopt, but we've kind of increased the robot use through collaborative robots, particularly with small companies, SMEs. There is a groundswell movement now to increase that. And there is funding to create automation hubs that can advise companies on how they can use automation to get to the next level. We already have things like the AMRC, the MTC and so on, but these are more small, localized hubs that would be particularly aimed at sort of smaller businesses. And that's where we see most of our sort of success stories have been with smaller businesses. Some of them 6 people, a machine shop with 6 guys, they've got 4 robots and the robots run throughout the night and that maintains their capacity. But that's one of the things, is that we need to invest in skills, the next generation of people. And we've launched a scheme last year, and we're doing the same this year, that we have 50 free spaces for apprentices to come and do a 2-day training course with us at Sheffield. Brilliant. Because we want to invest in the next generation of engineers. And it's good for them. They're more employable because they get that certification at the end of that. And it's our way of giving back into that sort of engineering and industry community, really.
That's brilliant. Yeah, fantastic.
So we do a lot with education, research, colleges. We're really proud of that. We've done a lot with the Scottish College Network. They've got 8 automation hubs, which they have our robots in. And that means that they're training the next generation of engineers as apprentices to take those skills out into the marketplace. And slowly but surely, England's doing the same, Wales is doing the same, Northern Ireland's doing the same. So, it's quite interesting of how the next generation of engineers are grasping those skills now to be able to be used, because we're going to need them in the next 5 years.
Yeah.
Manufacturing is going to be completely transformed in the next 10 years. And people going into that now, I think they're going to find it really interesting as a career. Yeah,
that's great to know that there's lots of efforts to upskill people and, like you said, train the next generation.
Definitely.
So last year, a rather unusual music video by a band called OK Go caught my eye because it had 25 robot arms in it. And I found out that those robot arms were from Universal Robots. So I couldn't miss out on this opportunity to ask you about it. Can you talk a little bit about the robotic technology that went into making that music video?
So it was a really cool video. I'm a big fan of OK Go anyway. And they were all coordinated together via a company that actually does this kind of thing. We've got a few examples of this where robots have gone into media production and so on. But that one was really cool because how they all worked together, they were all synchronized. So as the people were walking through them and they had mirrors on the end of them to reflect. It's a really interesting video of how it works together. It had to be completely synchronized. And there is a making of video on YouTube that you can see as well. It explains a little bit further about it. But that's not unique. We've actually, 2 years ago, Jean-Michel Jarre did a concert at Versailles. And in front of his keyboard was one of our robots with a camera on so it could sweep forward and show you his fingers as he's playing the keyboards.
Oh, cool, yeah.
And then the latest 1 hour video from Ed Sheeran when he's in New York. It's a continuous shot. It's done by the same people who did Adolescence. It's one of our robots that's on the bus that's filming him while he's sat playing music on the bus. So there's lots of these things. There's some really, really cool videos out there where our robots have been used for that technology, really.
Yeah, that's awesome. I guess the OK Go one is particularly cool because it's so many robots working together.
Yes.
And I know, like, OK Go, their brand of music video is always like it's one shot.
Yes.
So it has to be perfect.
Yes.
And, you know, robots are very reliable, but inevitably, whenever you try and do something to show someone else, the thing will always break. That's what technology does. So, like, I don't know how many takes it was, but it was quite a thing to orchestrate.
I think it took a lot of time to set up. There was a lot of preparation time, and I believe OK Go actually have got some connection with the choreographer. So whenever you watch any of their other videos, they're always those sort of, like you say, one-shot, expertly choreographed. And I think they had a lot of input into that, of exactly where the positions the robot needed to be as each of the member of the group were moving forward.
Yeah. Well, all the hard work really paid off. It's a very cool video. Mark, it's been really fun chatting to you today. I've been talking to Mark Gray from Universal Robots. Thank you.
Thank you.
Thanks for listening. If you enjoy Robot Talk, I'd really appreciate it if you could share the podcast, subscribe, and leave a review. And make sure you check out the awesome new Robot Talk merch that I've created by visiting robottalk.org/shop. I thought you might like to hear a sneak peek of this month's bonus episode. What is common knowledge in your field of robotics but surprises outsiders?
That some things are really hard for humans and really easy for machines. And the things that are really hard for machines are very easy for humans. So I think one of the things that wouldn't necessarily be obvious to maybe like some of my friends that aren't in robotics is that doing a backflip for a robot is actually much easier than getting the robot to unload the dishwasher. Much easier. Because I think when you're doing locomotion things, and even if you're doing really impressive locomotion things, you have a really simple goal. If your goal is to run, your goal is probably something along the lines of displace my IMU while maintaining upright. If your goal is to flip, it's probably to see a 360-degree rotation on one of my internal sensors and then finish in an upright, stable position. How do you specify, unloading a dishwasher and knowing if something is full or something is clean? There's so many difficult things to actually figure out in these like simple long horizon tasks that a robot doesn't necessarily have the intelligence to do oftentimes. So I think that's the big thing, is people kind of look at the backflips and the parkour demos and think, oh, that looks really, really hard. Probably because they're kind of thinking, well, I can't do that. But in actual fact, the hardest things in robotics would be like making the bed compared to, doing some of these flips or something. So I think that's one thing that would be maybe not obvious to someone that's not in the field.
Yeah, I mean, there's definitely something that surprised me as I've gone from being kind of an outsider in robotics to hosting a robotics podcast. And it's still, I have conversations with people now and it hits me again like, oh yeah, that seems like it should be really easy because I can do it without thinking, but a robot struggles and vice versa.
Yeah.
I think the diversity of what goes on. So listeners of the podcast will obviously know about the huge range of robotic solutions. But I think the general public don't realize quite how much AI, for example, has infiltrated, how much it's been integrated into daily systems. So in terms of things like our decision support systems, in terms of things like the smartwatches we have, or the Alexas or the Ring doorbells that we all use, there's a huge diversity of robotic systems, of AI-enabled systems out there. And I think the worrying thing from an ethical perspective is that the more these things become commonplace, the less we tend to interrogate them and the less we tend to question whether or not they're really ethically acceptable to us. In essence, they creep in by the back door. So I think that's the one thing that I would say to people. Have a look around at your life and see just how much AI-enabled technology, how much robotics is in there, and decide how acceptable you would find that.
If you'd like to hear more from this bonus episode, sign up as a supporter on Patreon by going to patreon.com/Claire Asher. You'll get access to the full catalogue of bonus episodes, plus lots of other cool supporter perks. Next week, I'll be speaking to Elmira Yadalahi from Lancaster University about robots for children. Until then, I've been Claire Asher, and this has been Robot Talk. Robot Talk Season 6 is sponsored by the Hamlin Centre, Imperial College London.